Hey everyone, so welcome back to another video on our channel, and in this video is also going to be one of the most important updates about the TCS NQT previous year coding question. So these questions we are going to discuss is a direct question from the last or previous year TCS NQT. This was in the 2023 TCS NQT asked questions and one of the most important coding questions we are going to see. So there is a trick in that question. We are going to discuss about the question. I am going to give you the code solution and also discuss and explain the method of solution as well. So first understand what is the question asking. Some prime numbers can be expressed as a sum of other consecutive prime numbers. So a prime number can be expressed as sum of other consecutive prime numbers. Suppose a prime number is 5. So 5 can be expressed as sum of 2 and 3. Okay, both 2 and 3 are also prime numbers. If we are adding these two prime numbers, we are getting another prime number, that is 5. Similarly, 17 is a prime number. So if we are adding another prime number like 2, 3, 5, 7, if we are adding these four prime numbers, then we are getting 17, that is one prime number. Similarly 41. So if you're adding 2, 3, 5, 7, 11, 13, these prime numbers, then you're also getting another prime number, that is 41. So in this way our code is going to run. Okay, so first of all, the whole question is based on prime numbers, so you understand this much, and we have to find those prime numbers who are sum of other prime numbers. Okay, so prime numbers who can be represented as sum of other prime numbers. So what is the task? Basically, we have to find out how many such prime numbers are there which are satisfying this property and are present in the given range. Okay, 3 to n. So first of all, we have to understand there will be input output. How the input output works, we have to understand. First of all, the input will only consist of one single number, that is n. That is the range. Suppose the range is given as 20. So we have to find how many prime numbers are there between 2 to 20 which can be written or which can be represented as sum of another or some other prime numbers. Okay, output format will give you the number or count of that type of prime numbers. So sample example, let's see. So input is given as 20. Okay, so output is 2. How only 2 is the output? So the explanation you have to see. Below 20 there are two such numbers. These numbers are 5 and 17. So we are not counting the number of prime numbers, we are counting the number of prime numbers, that is 5 and 17, which can be shown or represented as sum of other multiple prime numbers. So there is a prime number 7, but it cannot be represented as sum of two other consecutive prime numbers. Okay, because they have mentioned the sum should be starting from 2, like that. So also there is a prime number 11, but this cannot be shown in that way. So similarly, only two this type of numbers are there, 5 and 17, which can be solved and which can be represented as sum of this type of multiple other prime numbers, consecutive prime numbers. So let's see the solution now. So hope you are understanding the questions, and we are going to show you the solutions also in a few seconds. But before moving on, if you are new to our channel and if you want to see much more this type of TCS NQT preparation videos, like both coding and aptitude videos, we have already posted earlier, and again we are going to post till there is the exam is done. Also we post multiple different companies hiring, onboarding, off campus hirings, trainings, interviews and preparation strategies, everything related to this. So if you don't want to miss this out, make sure to click on the subscribe button, join our telegram from the description box, and also click on the bell icon. After subscribing, you can also join our WhatsApp channel. So here we have the solution for the particular problem. First of all, as you can see and understand that the whole code is based on and surrounding on prime numbers. So we are going to define a separate function to check if a number is prime or not. So we're going to define a is prime function. The return type will be boolean value. Okay, if the number we are passing, if the integer number we are passing is a prime number, it will return true. Otherwise, if it is not a prime number, it will return false. So let's see the definition of this. So if the number is less than or equals to 1, that is if it is 0 or 1, so as you know, 0 or 1 is not a prime number, so it will return false. Okay, and from 2 towards the prime number starts. So we are going to start a for loop from the 2 till the given number, whatever the number is given. Okay, so it will start from int I equals to 2, and it will run till when? Till I multiplied by I less than equals to num. So till I multiplied by I less than equals to num, we are going to check one by one if the number is divisible by I. So why we are using this I multiplied by I instead of using just I less than equals to num? Because this will increase the efficiency. So you have to first understand, suppose a number is given, suppose a number is given as 36. Okay, so if you are just checking if it is divisible by the numbers from 2 to its square root or not, only then we can find out that it is a prime or not. We do not need to check till all the numbers till 2 to 36. We can just check from all the numbers from 2 to 6. Okay, why is this working? Because if it is divisible by 2, that means it is divisible by 18. Okay, also if it is divisible by 3, that means it is divisible by 12, because 3 into 12 will consist of 36. Similarly, 4 into 9 will consist of 36. So if it is divisible by just any of these till 6, then it will be a prime. And if it is not divisible by any of the numbers till its square root value, then it will not be divisible by any other number as well. So that's how we can check if it is a prime number or not. One of the best approach to check if a number is prime or not, so that it can reduce the time complexity. So if it is divisible by any of the numbers, then it is not a prime number. So if num percentage I equals to 0, if num percentage I is equals to 0, then it is not a prime number, so it will return false. But if it is not divisible by any of this, that means it is a prime number, so it will return true. The return true is outside of the for loop. Even if it is divisible by at least one of these, then it is going to be false, because this is not going to be a prime number. But if it is not divisible by all of this, any of this cannot divide it and have a remainder 0, only then it can be a prime number. So the return true is outside the for loop. Next, the main function we are going to see. So first of all, we are going to take the input n. Okay, so we are going to take the number n, that is the range. Then we are going to assign a vector of boolean. Okay, what we are doing, we are assigning a vector of boolean. The name we are giving is going to be primes. Okay, what is the size of the vector? It will be size of n plus 1. Okay, it will be size of n plus 1, and we are assigning default value as false. So all the boolean vector default values is going to be assigned as false, and where later whenever we are finding any prime number, then we are going to assign that particular value as true. So it will be consisting of if the number is prime or not, like that. So boolean vector of size n plus 1 and default value is given as false. So why we are using this vector? For storing if a number is prime or not. Okay, like that, false or true values. So first of all, you are going to assign primes of 2 is going to be true, because we all know that 2 is the smallest prime number. We are starting from this. Okay, so and then we have used one variable count. We have declared one variable count and assigned it with 0, because this is going to be our answer. This is going to store our answer. How many such prime numbers are there, this count will be its count. So now we are going to use a for loop to traverse all the numbers from the given range, that is the 3 to n, slowly by one. So I equals to 3, I less than equals to n, I plus plus, like that. We are going to traverse one by one all the numbers and check if that number is if the number is following that rule or not. So first of all, we are going to check if the number is a prime or not. Only if the number is prime, then we are going to check if it is the sum of other prime numbers or not. Otherwise, if it itself is not a prime, then there is no need to check. Okay, so this will reduce the time taking also. So first of all, we are going to check if is prime of I is true or not. So if is prime of I is true, that means it is a prime number. Only then you are going to go inside this block. So now we are going to do what? We are going to set that primes vectors of I value as true, because this I number is a prime number, so the ith value of the primes vector is going to be set as true. Now we have found our prime number. Okay, so if we have found a prime number, this is not going to be the thing we are finding in this code. Okay, we have to find those prime numbers which can be assigned or which can be represented as sum of other prime numbers. So for that, we have to initialize another variable as sum with 0. Okay, and now again we are going to use a for loop, and the whole point of this for loop is going to be to check if the prime number we have got is the sum of all the other prime numbers, or if it can be represented as sum of other prime numbers who are less than it. Obviously a number cannot be sum of two or more numbers which are bigger than that, so we are going to check only till the, so we are going to check only from 2 to less than that number's value. Okay, so that will be done in this for loop. So we are going to use the for loop from j equals to 2 to j less than equals to I. Okay, so whatever the prime number we have recently found, we are going to check before that. Okay, we are going to check till before that by one again. So if again prime of j, so that means if we are checking again and again, if the we are finding any prime number, then we are adding that prime number to our sum value. Okay, we are adding that prime number to our sum value. So if j is a prime number, we are adding j with the sum value, and the sum is storing what? The sum is storing the summation or the addition of consecutive prime numbers from 2 to that prime number. Okay, from 2 to that prime number, and after adding the j for each iteration, we are going to check if the sum is now equal to our prime number, initial prime number, that is I, or not. So if it is equals to that I value already, we are going to increase the count by 1 and then break out of this for loop. Okay, like this, the second for loop, inner for loop. And if it is not equals to sum, then we are again going for the next iteration. We are finding the next prime number and adding the next prime number to the sum value, and again checking down if now the sum is that particular value or not, like that. Okay, so again like that, the inner for loop is checking if the consecutive prime number sum is up to the our prime number value or not. The outer loop is just checking for it for all the numbers one by one till 3 to n. So we're going to give the count as cout count, then it will give us the answer we are expecting. So that's it. If you have any queries regarding this, you can comment down.